Hello friends, Shivansh this side, and today we are going to solve impossible integrals as said by this guy in his book. Let me show you the name of this book. Almost Impossible Integral Sums and Series, and it's written by Cornell Loan Value. So I've been trying and they are not so much impossible, right? So this is 1.3. I haven't tried this one yet, so I was thinking that I should try it live. So let's start. Just a minute. So this is our question. And our mission for today is that we find a solution to all four integrals, and let's see what we can do. Because I'm really clueless that I've just put tomorrow. I put it as a post that uh, coming up with these deadly integrals, and I was like thinking that I would like to solve it live, and then today in the morning, just 16 minutes before I told that I'm coming live. So let's start. So let's first of all read the question. Let n be a positive integers, then prove that following equalities hold. Okay, so in is our 0 to 1 x n minus 1 log 1 minus x. And here I think it's self assumed that log is ln, natural logarithm. I would be lighting it as ln only because I don't like this notation log. Anyways, and now jn, it has power of 2, kn it has power of 3, and ln has power of 4. And what we have to prove that it is equal to minus hn by n, where hn is hnm is nth generalized harmonic number of order m. So that means if it's 1 or nothing is written, then it means 1 plus 1 by 2 till 1 by n. Okay, so minus hn by n. And in second part, when we have square, it's saying it's 2 by n sigma of hk by k, and it is equivalent to something something which we would see. Then in third part, it's saying it's sigma of minus 3 by n into sigma of something something, and by coincidence this something something is this only. which is sigma of this. So I think it's like it means to say minus 3 by n, sigma of hn by n, and at fourth it's sigma of this. So like before deriving, we can simply write what the generalization is. It's integral 0 to x to the power n minus 1 log m 1 minus x dx is equivalent to k is 1 to n, and write this how many times? M minus 1 times, I guess. For m is 1, we have to write it 0, sigma 0 times, 2 sigma 1 times, right? M minus 1 times, and if square, yeah, minus 1 to the power m, hn by n, hk by k precisely. Like basically it means we have to first of all do it sigma, like minus 1 by m is outside every bracket. We have to do it sigma m minus 1 times hk by k is sigma. So like we have to prove it. I'm just telling you the generalization of the same thing. So let's start. I don't think I would be proving this. Let's see what we can do right now. So it's integral 0 to 1 x n minus 1 log 1 minus x. So here, what we can do is, I guess, apply series of this x to the power n minus 1 minus outside, and its series is x plus x square by 2 plus x cube by 3, and it goes on till infinity. And now it's goes on till infinity, minus integral 0 to 1, it's x to the power n plus x to the power n plus 1 by 2 plus x to the power n plus 2 by 3 dot dot dot, and now integrating it term wise, it's 1 by n plus 1, right, is plus 1 by 2n plus 2, and this goes up till infinity. So writing it in general form, what we want is it's going till infinity, right? R is 1 to infinity minus outside, it's 1 by Rn plus R, I guess. And it somehow makes feel of method of differences, right? Like telescoping sum. So that I would multiply my 1 by n here. Sigma r is 1 to infinity n plus r minus r by r into n plus r, and it's minus 1 by n. Sigma r is 1 to infinity n plus r by n plus r, 1 by r minus r by r cancelled, 1 by n plus r. Now seeing term wise precisely what we can do, r is 1 means 1 by 1 minus 1 by n plus 1 plus 1 by 2 minus 1 by n plus 2, and goes up till infinity. how it can be reduced to Hn. Okay, so somehow I'm thinking that these n minus 1 would get cancelled in the next round when it would start by 2n. So just to prove that, let's take n is 5. Okay, so 1 by 1 minus 1 by 6 plus 1 by 2 minus 1 by 7 plus 1 by 3 minus 1 by 8 plus 1 by 4 minus 1 by 9 plus 1 by 5 minus 1 by 10. Oh yes, oh yes, oh yes. Plus 1 by 6 minus 1 by 11, and this gets cancelled. Plus 1 by 7 minus 1 by yes, this also gets cancelled. So precisely for n is 5, we are getting till 5 and rest all are getting cancelled, right? I hope you are convinced with it. Even we can write it in general form, but I don't think it's necessary. So basically, these all terms would get cancelled in future, and till 1 by n they would never get cancelled. So our answer is, as it was said, minus h by n. Now it was our in. So basically we have proved our first part. In is minus hn by n. And now as we can see that, like before just seeing, as they have said in, we have to prove that Jn is minus sigma k is 1 basically to n ik. I am thinking that why not just like, instead of going straight from writing integral, why not just prove it simply? Basically, like uh, I'm saying that let's write ik integral 0 to 1 x to the power n minus 1 log x minus 1. It's k minus 1, right? Hmm. Now reversing the signs, Jn is basically like what, as you can understand, what we have to do. We have to somehow prove that this reduces to the integral where it has square over here, and I don't think that we can do it, or we can do it. Anyways, let's see. First of all, let's see in question that it starts from k. Oh, sorry. Does it start from k is 1, the sigma thing? It starts from k is 1, right? So that means hn minus n. If n is 1, then also it's valid. h1 by 1, h1 minus h1. So yeah, and just for fun fact, I guess that limit n tending to infinity, where does this goes on that hn by n limit tending to infinity, because it's infinity by infinity form, right? It's a well-known fact that zeta at 1 diverges, 1 plus 1 by 2 plus 1 by 3 diverges. And I made a very good video on it. You can see it on my channel. So uh, our in was like, basically we aim to find n tending to infinity, and our in was basically integral 0 to 1 x n minus 1, which of course doesn't, like n minus 1 can be written as n because infinity, right? So this is a line from 0 to 1, that x is a number between 0 to 1, so it tends to 0, and 1 minus, it's independent of infinity, right? It's independent of n. So is this term dominating, and we can simply say it's 0? Hmm, seems to be right. Like, yeah, we can do it by writing it series x minus x square by 2 plus x cube by 3, and if x to the power n multiplies to all, like x is between 0 to 1, so individually all terms are 0, so it means this limit is 0. Oh, I've never imagined it. That means that natural number, the number of natural number, is bigger infinity than sum of the reciples of all natural numbers. That's great. Well, anyways, let's return back to our topic, and I think we're stuck over there. Yeah, yeah, it's k2 1 to infinity. So let me pull out integral sign and log x minus 1 sign. It's sigma k is 1 to n x to the power k minus 1. Oh, sorry. It's not x minus 1, it's 1 minus x. Now, what does this mean? Till n, of course. It is basically 1 plus x square dot till xn minus 1, and this is a well-known GP formula, xn minus 1 by x minus 1. Substituting it over here again, jn is minus integral 0 to 1 ln 1 minus x by 1 minus x 1 minus x to the power n. Mm, Now, right now, I have one more idea, that let's use King's property of like definite integrals. And basically, King's property means that integral a to b fx is equivalent to integral a to b f of a plus b minus x. Sorry, x minus a. Sorry, a plus b minus x. My bad. So ln, like basically we can put here 1 minus x in place of x. So it's minus integral 0 to 1 ln x by x and 1 minus 1 minus x to the power n. If I put ln x as t, one more thing. What if we apply integration by parts over here? Because then this will like take, like I would integrate this function and differentiate this one. Then I think it would out. It seems to be right, because first of all, let me write what integration by parts is. Basically, integral of, in every video I tell this to everyone. Uh, this is just leave f indefinite of g minus whole integral f dash integral of g. So here we are taking g as ln x by x, and f is 1 minus 1 minus x to the power n. So writing it 1 minus 1 minus x to the power n into integral of g with ln x by x, and integral of ln x by x is pretty much simple. Putting ln x as t, dx by x is dt. Oh no, it's not giving us ln x square, but it's giving us ln of ln x. No, 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 no. Sorry, sorry. My bad, my bad. It's also given a factor of half. Okay, so to ln x is t. What I have written, I have not even understand. Dx by x is dt, right? So here we have dx. We can write it as dt ln t, so it's t square by 2. Ln square x by 2 minus integral of its derivative. So derivative of 1 is 0 minus out n 1 minus x to the power n minus 1. So I think we have done it. Yes, we have done it. N minus 1 n out, and writing integral of g ln square x by 2. So now we have to put limits from 0 to 1, and putting limits here from 0 to 1, putting 1 here, this 0, putting 0 here. It is a 0 by 0 limit, like something kind of basically ln 0 minus infinity into 0 type of limit, but it leads to 0 because ln x is a very slow function and x to the 1 minus is a very fast function. Okay, like you can even prove it by let's slow and fast is a stupid theory kind of thing, right? I really don't want to prove it. Please leave me. So it's minus n by 2 integral 0 to 1 1 minus x n minus 1 ln square x. So basically, what was this? I think this minus should come here. No, it should come here. Yeah, it should. So let's see above that was this. This was basically, hmm, yeah, oh, we are missing on this negative. So it's my mistake, right? Like we wrote negative till here and below we forgot it. So there is a negative outside this whole bracket, and this negative gets cancelled. So basically, using our sigma properties, we get that j is equal to integral 0 to 1 minus x to the power n minus 1 into ln square x, and using King's property again we get the jk or jn precisely in form they have asked. Oh, this is cool. I did it. Yeah, so we have done this thing, and now it seems to me that all other part would be equivalent, right? Because the next part, what we have to simply prove is basically, let's generalize it because now I think the thing is same basically. mm, let's be out of the question and define a function. Can you please tell me a good Greek variable name? I'm just seeing comments and I don't think anybody is here watching it right now. Let's mute this side so it doesn't disturb us. Oh, yup, there are some people like they saw and they went away. Anyways, yeah. So let's say phi n. So what's our phi n? Phi n is integral 0 to 1 x to the power s minus 1 ln, like phi t. X to the power n minus 1 ln to the power t of x minus 1. 1 minus x, my bad, my bad, my bad. Dx. And what we have to prove is that, as we can see here, mm, basically I hope you want, like, in terms of phi, this is phi 1t. What, like, I forgot the, sorry, phi t. It's just phi 1. This is phi 1. It's not called phi, it's called psi. psi. Psi 2, this is psi 3, this is psi 4. And what we have proved, that psi 2 is minus sigma uh, k is 1 to n psi 1 k, phi 2 n. So basically we have to define phi 2 in terms of this n, right? This is phi t n. And basically, if we prove this thing, what we prove, if we prove this thing generally, like this we have proved in this, like, just 5-10 minutes before. Now, if we prove this thing for general t and t minus 1, I think our work is done. So basically, what we need to prove is that phi t n is equals to negative, one more thing, sorry, I missed a term over here, minus 2 by n, right? So 2 to t minus t by n sigma k is 1 to n phi t minus 1 k. So basically, this is the thing we simply want to do for this video ahead. We have proved it empirical, like, we have proved it for the first part. And another thing I think I would do at the end of this live, I would try bringing this in this form and this in this form, which I don't seems very cool. And I think you must be convinced that if I proved the above result, and if I found phi 1, which I found for you, of course, using series, and then we have done all questions, because this is phi 1, this is phi 2, this is phi 3, this is phi 4. So our motive is first of all to prove this thing, and then to basically bring in higher order of HN forms. This is a very stupid thing. Oh, but I don't want to. Yeah, okay. So copy, and let's go on to the new location in this file, because that's pretty cluttered. Let's paste it over here. Oh, where is it gone? Yeah, here it is. Right, and let's change the color just for fun. Let's make it blue or white. White. So, what is 5t minus 1k? Our phi, like we are going on the grounds of way we did for phi 2 and phi 1. It's not phi, it's psi. Sorry, my bad. Psi. Integral 0 to 1 x k minus 1 ln t minus 1 minus x. Right, and it's sigma from k is 1 to n. Now switching sigma and integral, and like basically you can pull out the terms which are like which do not depends on variable of summation, that's k 1 minus k x. We can simply pull it out. Now sigma n k is 1 x to the power k minus 1, and we proved it that, like not proved it, basically we know a formula for it. 1 minus x power n minus 1, it's 1 minus k into 1 minus k ln t minus 1 1 minus x integral 0 to 1 dx. Now again using King's property, we are definitely going on same lines we did it for psi 1 and psi 2. Ln t minus 1 x by x 1 minus 1 minus x to the power n. Oh, you know what? I missed one thing, and that one thing is that because psi t minus 1 is including one more term, that's t by n. So to multiply here n by t minus 1, like basically we can simply write t by t minus 1, not a big issue. And if you haven't understood why I'm writing this, you would see it later or below. Okay. Now again on the same idea, we can integrate this thing. So applying by parts by integrating this and differentiating this. Again, the first sediment would be 0 as I proved it earlier. It's minus, you can see minus of parts. Its derivative is n x n minus 1, and its integral is ln t x by t. Okay, and pulling it outside, minus n by t, we got psi t, right? Oh, I think we have done it right. Okay, anyways, like say it as C and we will generalize. But I think you're understanding the feel what I'm trying to say. This is what? This is sigma k is 1 to n psi t minus 1. Sigma psi t minus 1. So what we have done, what we have proved is that psi t is minus t by n sigma psi t minus 1. Now let's start, like it's a recursion, of course, as you can see. Mm, hmm. Let's start from psi at 2. Psi at 2 is minus 2 by n, and sigma of psi at 1. And what was psi at 1? Minus hn by n, and this gets cancelled. So basically our psi 2 is 2n sigma hn by n. And comparing it with our different, basically psi 2 was our ijn. In was psi 1, where it's gone. Oh, here it is. Let's bring it here. So sorry. So this is the thing. And similarly, we can find 5354. This brings end to our challenge. And okay, as I told you, I'm not interested in bringing these forms because I've never done it and I even don't want to do it. So, anyways, if anybody of you is doing it,